Alright, in this video we're going to address an issue. We see those little kind of paired up steps, and then it happens with this one right there, and we're going to fix that with the escalator. It happens for a pretty simple reason. It's because I have a debug thing which is going to print out how many steps we have, the step length, the spline length, and then the distance single step distance here. So I'm just gonna have this print out right away, and then I'm just gonna grab this so it doesn't go away. Okay, and I can stop that, and here we go. So if you look, there's 29 steps. This includes the first and the last. So the important thing to note here is, because it's kind of like a fence post, if we're wanting to know the total length of all the steps, we don't actually count the last one. So for example, this is 1, 2, 3, 4, 5, but there's actually 6 like fence posts, so to speak. And the same is true with the steps. So if we would do the math, so this is 20, so we're going to do 19. Each step is 45, so 19 divided by 45, which is 855. So that's like how much distance the steps take up as they're moving around the spline. However, if we look at the actual length of the length of the spline is 866.39, whatever that is. So those don't actually match up perfectly. So that's where, when we start this, we get that little bump, right? Where they're not every cycle. You end up with a few steps that aren't quite lined up with the rest of the steps. So a simple solution to this, at least in our escalator situation, is, since we don't actually, the end of our escalator is usually in something, we can stop it a little bit before. We can kind of do the math and like, well, let's just make the step end at the perfectly divisible one, so that way the steps are nicely in sync. If this wasn't available to us, let's say you could see the entire length of the thing, there's other solutions. Maybe you could kind of mathematically divide the length of the spline by the amount of steps you want, and then you could get a similar result. But the implementation that we're going to work on is we're going to replace this spline length with the divided system. And we're going to do that, and we're just going to make a function. We'll call it step distance to reset. And we are going to make this a pure function. And all we want in it is we are going to get this by this, and that is what we are going to want right there. And then an easy way to get an output is just to press the output and then delete that. And we're just going to put that there. We can connect this if we want. So we have the step offset. So this initial number here is going to give us how many steps are needed. And then in this one, and then the length, a divisible length for the spline. So this is going to be the distance that's like close to that spline length, this distance here, which is not quite, but it's within a step of the end. So that way it actually divides correctly. We can just drag this function in and replace everywhere we would normally get the spline length, which is going to be these 4 use cases. Right there and right there. And we're just going to do Control-Shift-S to save, and if we play, notice there is no bump. The steps are moving through perfectly. Granted, the kind of side effect of this is it doesn't actually, let's see if we can grab the spline here. Let's do the other one actually. It's not actually going all the way to the end. It's spawning right about here, which is what we want, so that way the splines are always matched up and you don't get that step that looks a little quirky every once in a while. All right.